So our focus as we study noise and interference is going to be noise. But I thought before I leave the topic of interference, I wanted to just talk about interference and ways of eliminating signals which kind of come in because of interference from outside signals in this particular video. And you will be learning more about interference in the third year module where which is called medical electronics and neural engineering, where you will be talking about interference in a little bit more detail. So let's just think about interference, and particularly let's look at the power supply interference that you get when you measure biomedical signals. Okay, so imagine uh, in this case that you have a 50 hertz source here, a power supply source. Okay, and this source is powering an ECG system. Okay, now even as it is supplying this ECG system, what you can see is that you will have certain parasitic capacitances by which this line is connected to the human being, to the ECG leads themselves, uh, and the ground is connected to the person, and so on and so forth. Okay, so there are these parasitic capacitors, and basically, one way to think about it is there's a conductive plate or a conductive wire which is running the 50 hertz signal, and you are a conductive person, and they are acting like two plates, and a capacitance is formed in between them, right? So, so these signals are going to result in some kind of 50 hertz signal being picked up by the body, picked up by the ECG leads, and then given to the ECG system. And perhaps if you have not designed your circuit carefully, maybe being amplified. Okay, so in here I have a clean ECG signal, and you could have a lot of 50 hertz noise associated with it, and it may look like this. So really bad, right? Yeah, your ECG signal could be swamped by 50 hertz interference. And if you haven't really seen this before, don't worry. I'm almost certain that when you make your ECG circuits, you will see 50 hertz noise quite a bit. Okay, and if not, let me know, and I can make one or two small tweaks in your circuit and show you what 50 hertz interference looks like. Okay, so how do we get rid of this 50 hertz noise? There are two approaches that we could use. One is you sit in a Faraday cage. A Faraday cage is basically a place where all kind of electromagnetic radiation is stopped. Uh, uh, okay, so that the parasitic capacitances from the 50 hertz noise is not carried on to you. You are not connected to it. The Faraday cage stops that. So that's one way of doing it. Another way of doing it is by just using wires that are twisted around together. Okay, what that means is, so if you are recording ECG from yourself, the wires that are going are twisted around each other. The reason why that helps is because then the uh, noise, the 50 hertz signal that is induced on both the positive and the negative wires are the same, and when you take a difference of those two, it gets cancelled out. Okay, so the first step in almost any biomedical measurement system is a difference amplifier or a differential signal. And if the same 50 hertz signal is imposed on both the wires, then that signal can be cancelled out. And the reason why the same signal is imposed is because it is twisted. So spatially, you cannot distinguish between the two wires. And therefore, you have the same 50 hertz signal on both of them, and they can be cancelled out. So those would be some of the ways. More about interference in year 3 if you're taking that course. In the next few videos, we'll talk about noise.